I certainly can. Thank you very much, Kim, and welcome to those who are here and those who are in the process of arriving and getting placed in. Today's virtual meeting, as you know, is about it's from 475 and it's water, air, and vapor control and the things that you can get to support high performance projects. And when you see Ian, you'll see that he has some of those things that you can use for high performance projects in the graphic that is behind him there. So we're Passive House California, and we are a part of the PHN, the Passive House Network. If you belong to, as you're a member of Passive House California, you are automatically a member of PHN, or vice versa. If you're a member of PHN and you live in California, you're automatically California. We are all connected to the International Passive House Association and the Passive House Institute. So that's there. And first, I want to say thank you to 475 High Performance Building Supply. They are, they're one of our sponsors, has been since literally since the beginning. So thank you to that. I want to thank all of our sponsors. We have our silver sponsors, our Small Planet Supply, Earthbound Homes, and Minotaur. And then we have a number of supporting sponsors, 475 being in the upper left-hand corner there on my screen. Well, in fact, it will be on others. And Rockwool and FGA, and I'm going to have to move this so that I can get over and see Ream, Stiebel Eltron, Intelligent Membranes. That's another good membranes. The Heinrich team, Pete Moffat, Fergus Garber Architects, Hayward Lumber, CPHBA, Good Space, Presoko. So all of those are our sponsors, and we want to thank them. They show up on the newsletters and they're on the website and things. We are in the process of getting some new sponsors as well because we're gaining momentum here. I will go ahead and stop share and turn it over to Kim at this point.
Thank you everyone for joining me today. It sounds like a few of you are familiar with 475, and if a few of you aren't, that's all right too. So, today in my presentation, I'm going to be talking about water, air, and vapor control and the design support that 475 as well as myself can offer for your high performance and passive house projects. So brief introduction of myself. My name is Ian. I'm a product consultant at 475. I've been with 475 since 2018. I live in Oregon and I actually grew up in Healdsburg, California. My parents lived out Dry Creek Valley for 40 years. So I'm very familiar with California. I've got lots of family in Southern California, San Jose. I love it down there. It just happens to be a little cheaper in Oregon. So I happen to be up here. And a little bit about my work history. I used to be a canvasser on the streets of Seattle, waving people down for Greenpeace donations. That was fun. I worked on an energy efficiency rebate program in California, helping commercial businesses get upgraded to LED lighting. I worked for an engineering consulting firm up in Portland, Oregon, working on regional energy efficiency studies, also on Building America indoor air quality studies using blower doors, assessing ventilation systems, indoor toxins, things like that. So that was really cool. And I did work for a passive house builder in Portland for a little while as well. I'm a certified passive house tradesperson, certified ResNet HERS rater, and a certified BPI building analyst. And so, 475 is a really great place. We offer resources in addition to products. So if you're not familiar with our ebooks, definitely go to the website and download those. You can download them in PDF versions, or you can download the CAD details and put those plans right into your plans that you're creating too. And a little bit about 475. We were started back in 2011 by two architects who wanted to design to the passive house standard, and they realized there weren't that many great materials in the U.S. market to meet the standard. So that's how 475 was born. Here we are 13 years later. We've got about 25 employees, and the company is based in Brooklyn, New York. And we have, I think, 5 or 6 warehouses throughout the USA and Canada. Serving the California area, we do have one warehouse in Portland, Oregon, and then another warehouse in Denver, Colorado that both serve California and beyond. And so at 475, this is kind of a high-level overview. We offer the Proclima products as well as Stego for water, air, and vapor control. We offer the Gutex wood fiber insulation from Germany. We do triple paned glass roof systems with Lamilux, and for pitched roofs with the Facro skylights. We sell the quality control tools for PHI. And then we also sell the Brink and Luno systems for your heat and energy recovery ventilation. So, what is high performance? I think all of you on the call know you're familiar with Passive House, and Passive House is an amazing tool that can be used to reach high levels of comfort, energy efficiency, resiliency, and high quality homes. And as you know, it's based on five principles, right? Continuous insulation, no thermal bridging, triple pane windows, air tightness, and heat or energy recovery ventilation. But what the Passive House standard doesn't sort of define is what the home is built out of. You can design it to a really high standard, but it could be made with some materials that are not great for the environment and for people, and that don't have the best water management systems within them. So at 475, we really like to promote the use of foam-free assemblies. And when it comes to foam, our mantra is less is best. So when it comes to foam, it's somewhat irreversible, especially when we're talking about closed cell spray foam insulation. Once it's sprayed in there, it's pretty hard to remove if you ever want to make a change to your project. It does have a degrading R value over time. So the R value you pay for today is not the R value that you get 5 or 10 years down the line. Foam is also not dimensionally stable, which means that it can crack and shrink over time. And because wood framing members expand and contract due to temperature and humidity changes, the spray foam insulation can crack away from the framing members for that reason too. This picture in the middle here is actually in Truckee, California, that was sent to me by a water management consultant in the Bay Area. And this was, a month or a few months after an installation. So already degrading very, very quickly. In addition to that, the application of spray foam insulation can be a fire hazard. It's not made with the best materials, and it does have high levels of embodied energy. So there are other insulation products we can choose that manage water better. I'll get into that later. That have lower levels of embodied energy or negative embodied energy with respect to like plant-based insulations. So yeah, there are better products out there. We can make better assemblies, and we can make them more robust, resilient, sustainable, high performance, and higher quality, and still enjoy our homes just as much without foam. All right, so today I'm going to talk specifically about water, air, and vapor control. And then after that, I'm going to talk about some details that are being used in California on specific passive house projects, and then a few 475 products that are being used to help meet that air tightness, water, and vapor control standard of the passive house certification. So when it comes to water control, I'm sure you all know this, right? We have to shed it away from the building or else it will destroy the building very quickly. And it never rains in California, right? That's what people think. But over this 23-day period, a couple years ago, this was the wettest 23-day period in history in California. I think it was during an El Nino year or maybe La Nina. I think it was La Nina because last year was El Nino. So I'm going to stick with that. So water management, really important, even in California, and maybe even more so because it can be kind of light on rain and then get these really, really heavy events. And so rain screens are a great way to manage water, and rain screens can be used on the walls or on the roof of projects, especially pitched roofs. So the rain screen is defined as the gap between the WRB and the siding. And that gap can be anywhere from 1/16 of an inch to 2 inches deep. The benefit of going a ½ inch or greater is that you actually get air movement through that rain screen. So if you have openings at the bottom of the wall, openings at the top, and you make it at least a ½ inch, you can have air that can actually move up and through that cavity. So if you have wind-driven rain, if you have water that gets behind your cladding system, having a rain screen gap will, for one, allow that water to drain out and away from the building, and then will also allow air to move that water vapor out. So it can help dry out your buildings very, very quickly. So now talking about water-resistant barriers, WRBs, house wraps, most products on the market are microporous membranes, which you can see in the image in the bottom there under a microscope. So microporous membranes typically made out of a plastic material, and that plastic material is not vapor permeable. So they have to stretch that material or put these micro perforations into it so that water vapor can get out of the building because we don't want to trap water vapor in the building. It's kind of that old definition that builders and I think architects have used in the past that buildings need to breathe, right? But now with Passive House, we know that we don't want buildings to be air leaky, but we still have to let the water vapor out. So microporous membranes, they're stretched. They have micro tears or micropores in the material. They have no active vapor transport, so they rely on air to move that water vapor through those holes. And so those holes are great for keeping things vapor open, but it's going to degrade how watertight your assembly is and how airtight it is. So at 475, we sell the Proclima system. You'll learn more about this later on in the presentation, but the Proclima system uses a monolithic membrane, which you can see in that little picture above, and it's completely monolithic. There are no micro tears or micro pores in the material, and it has active vapor transport through the material. So water vapor molecules hit the membrane, and there's actually a molecular chain that allows that water vapor to move through the material. What this does is it creates a much more watertight and airtight material, typically 100 times as airtight as a microporous membrane, and it resists a 33-foot water column. It's also why the Proclima membranes can not only be used on the walls of your project, but on the roofs as well, because they are so watertight, as you can see in that picture on the bottom right. All right, so now let's talk a little bit about air control. Obviously, if we control the air that's coming in and out of our buildings, we can keep it fresh and we can keep it clean and we can have healthy levels of indoor air quality. As I'm sure you all know, air control delivers energy efficiency, but it also impacts how much moisture can move into our assemblies, and it also impacts the R value of our insulation. So what's great about air tightness is we can use the blower door to test the air tightness of our home or building. So unlike maybe some other goals that we have, measuring air tightness is very, very easy. You set up this blower door system, you pressurize or depressurize the house, and you can isolate and find where your leaks are in the building. So just a really cool tool that we have for our high performance projects. And so when it comes to air tightness, it does deliver energy efficiency, right? Which can uh, create the need for smaller mechanicals, right? You can actually reduce the size of your mechanical systems. And so this specific chart is looking at the Darmstadt Passive House. It was the first Passive House project built in Germany to the PHI standard. And what we did is we took the Passive House software and we adjusted the air tightness for the building, as you can see from 5, 3, 2, and 0.6. So we adjusted the air tightness of the building and then looked at the heating demand in kBTUs per square foot per year. And you can see as the home gets more and more airtight, it reduces the energy consumption. And so one thing you might notice about this is you're like, hey, I thought I heard that Passive House reduces energy consumption by 80 to 90%. And it usually does. But for this project, this is a Passive House project, right? It's already got triple pane windows. It's oriented properly. It's probably got exterior shading. It's got high levels of insulation, and people have been cognizant of thermal bridging. So this is only adjusting the air tightness of what's already a really great building. So that's why we only see that 60% reduction. All right, so air control also fundamentally impacts how much water vapor and moisture gets into our walls. So the Building Science Corporation, they did a study and looked at the amount of water vapor that diffused through a 4x8 sheet of gypsum board over the course of one winter, one heating season, with an interior temperature of 70%, 70 degrees Fahrenheit and 40% relative humidity. And what they found is that about a third of a quart of water diffused through that 4x8 sheet of gypsum board. Now, what they did next is they cut a 1 inch by 1 inch square hole in that 4x8 sheet of gypsum board. And what they found is that up to 30 quarts of water entered that wall system. So 100 times as much moisture moved due to air movement than due to water vapor diffusing through materials. So the big takeaway here is air leaks can become moisture leaks, and they can become moisture problems very, very quickly. Controlling the air and controlling the air that moves through our insulation can also impact our R value. So if any of you have been outside on a cold, windy day, just wearing a fleece, you'll know that that air that cold air that cuts through that fleece really degrades how warm that fleece keeps your body. But as soon as we throw a hard shell over that, we're preventing air movement through our insulation. We stay nice and warm. And that's because insulation, it's not the fiberglass, it's not the denim, the wood fiber. It's actually these tiny pockets of air that are trapped by the insulation that create the R value. So if you have air movement moving through your insulation, it's not going to do you much service. So we recommend air sealing your insulation on all 6 sides to really enhance and get the R value that you're paying for. All right, so when it comes to air tightness, right, we want to use really great materials, durable materials that are going to hold up to the life of the building. We want to simplify the details so that it's very simple for the person on site, the laborer or the contractor to um, put in the airtight strategy. We want to consider the sequence because the water barrier could also be the airtight layer. And we don't want to make something airtight but water unsafe. We want to seal up penetrations to windows, pipes, and wires. And if the air barrier gets damaged, we want to make sure that we can repair that, verify that it's repaired, and protect it over the long term. And so touching back on foam, just a little reminder here, right? It can be sprayed on too much, too wet, too cold. It can set up wrong during the application process. And then you have a big lift of, hey, how do we remove this material? How do we get it airtight? But again, over the long term, foam is going to shrink. It's not dimensionally stable. It will crack away from framing members, creating air leaks and thermal leaks, potentially moisture leaks as well. And remember again that wood framing members expand and contract over time due to temperature and humidity changes, and that can cause the spray foam to crack away from the studs as well. So connections are essential as well. We talked about penetrations, windows, wires, pipes, things like that. The traditional approach is to use caulks that can dry out and embrittle over time. There's a new approach. The Proclima products use a solid acrylic adhesive, which is tested for 100 years of adhesion. It's non-water soluble, meaning that if any water engages with the adhesive, it will not wash the adhesive away. This Tescon Vanna tape that you can see in this picture here, builders have put those on their jeans, put the jeans through the wash over and over again, and the tape does not come off. So this solid acrylic adhesive, again, it's permanent, will last the life of the building, and our tapes can stretch a bit too as the building stretches over time, and the adhesive won't dry out or embrittle over time. All right, so when it comes to air control, your air control layer can be in a variety of places on the wall, right? It can be the WRB on the outside of the wall, it can be the taped plywood sheathing, or you can use an interior air control layer like Intello Plus that you can see behind me, as well as in this photo. And the benefit of using an interior air barrier, especially in a cold climate, is you can minimize condensation issues. So, in the summertime, when you've got a nice cold drink, that warm air hits the side of that cold drink, the air cools down and it leaves behind moisture, right? That's why on the outside of our, canned beverages or glass beverages in the summertime, we have moisture on the outside. So we really want to prevent that from happening in our walls as well. So by adding an interior air control layer, you're also reducing the condensation risk in the wall. So just an additional benefit of going with an interior air control layer as opposed to one that's on the sheathing or on the WRB on the outside of the wall. All right, so third section here on vapor control. I think none of us wants our new projects to look like this a few years down the line, right? We want to avoid mold and rot. And so with high performance projects, high R value projects, very, very airtight projects, you have less heat energy moving through your assemblies, wall, floor, and roof. Older buildings like the one you see on the left here, this is in the wintertime. This is using an infrared tool to see, where the heat is coming from on the building. And as you can see, this building's not insulated very well. It's probably not air sealed very well. It's using a very large mechanical system to heat the building during the wintertime. And the benefit of this is that you're heating up the wall assembly and you're driving a lot of heat through it, which can minimize condensation issues. It can minimize any moisture issues in the wall because you have so much heat energy moving through it. But in passive house walls, highly insulated walls, airtight walls that have very small heating systems on the inside, you do not have as much heat energy moving through the wall systems. So this is where we really need to start thinking about how our wall assemblies are going to dry out, because the only way they're going to do that is through vapor diffusion, which is a slower process. So when it comes to vapor drive, vapor water vapor tends to move from high concentrations to low concentrations. But it also moves oftentimes from areas of high temperature to low temperature. And the reason for that is that warm air can hold more moisture. So it typically has a higher um, vapor pressure. So in the wintertime, when we're heating the inside of our homes, generally speaking, the vapor drive is going to be towards the cold side of the wall. So the best practice approach would be to have a vapor retarding material on the interior side of the insulation. So in this image here, this is going to be that blue line. This is that vapor retarding material. So, all the pasta that we're cooking, boiling, all the moisture that's coming out of our breaths, all the shower, that water vapor is going to try to migrate out of the wall system. So if we have a vapor retarding material there, we can prevent that water vapor from getting into the assembly in the first place. And then on the outside of the wall, since that vapor dry is naturally going to want to go out, we want to have vapor open materials so that the water vapor can escape and keep our walls dry. So in the summertime, the situation reverses, right? Now you might have air conditioning running on the interior. You might be really, really hot outside. I was just talking to someone in California earlier, and it was 117 where they were at. It sounded like a couple hours south of Bishop in the desert. So I hope they have air conditioning out there on those hot days. Um, and so let's imagine you had a window leak. You got lots of water in your wall. And now you have the western sun baking the side of your house. That's going to drive the water vapor into the home. And so that vapor retarding layer, we want that to be able to open up and be vapor variable and allow for inward drying. That way the wall can dry either towards the outside during the winter or towards the inside during the summer. That's best practice. And so coming back to foam insulation, in this case, rigid foam insulation, you can see maybe some snow here in the picture. So this is in a cold climate. Um, the foam insulation is essentially vapor closed. It's not going to allow any water vapor through it. And this foam insulation, it is going to make this house more energy efficient. It is going to make this house more resilient. It is going to make it more comfortable. But in the wintertime, when that vapor drive is naturally towards the cold side of the wall, that water vapor won't be able to make it all the way through the wall. So we're essentially creating a vapor barrier in our assembly that could create moisture issues. And just to expand on that a little bit more, this is a study that was done by the Building Science Corporation, and they looked at 4 wall assemblies in Minneapolis, Minnesota. And they wanted to understand the humidity levels at the interior face of the exterior sheathing. So again, they wanted to test what the humidity was over the course of the year at the interior face of the exterior sheathing, which is represented by that y-axis. There's the percentage of humidity. So what they did is they put 4 walls together. And as you can see, the 2x4 and 2x6 walls with standard construction, they never went above 80% relative humidity. But the walls that did have 1 inch and 4 inches of XPS insulation, those walls actually had relatively high humidity at the interior face of the exterior sheathing over the course of the heating system or the heating season. So this is an indication that water vapor was trying to move to the cold side of the wall. It was building up within the sheathing and couldn't get through the foam insulation. And mold does start to grow at above 80% relative humidity. So is this wall going to fail prematurely? It's anybody's guess, but it is an indication that water is getting stuck in there, water vapor. And so what's important to remember is that foam makes our buildings less tolerant of moisture, just like OSB versus plywood. I think we can all agree that plywood is a more resilient construction material, even though OSB is very popular in the market. But OSB is just not as tolerant to moisture as plywood is. And so by adding foam to your projects, we're making our projects less tolerant of moisture and more risky. And another thing that's important to remember is in that study we just looked at, right? That was only looking at vapor diffusion up on this top left-hand side, which isn't that much moisture, but we could have wet construction. We could have a leak, near one of our windows where lots of moisture gets into the wall. And so there's really no absolute protection against moisture. So we really just want to have a greater amount of drying capacity than our moisture stress. So we like to promote vapor open exterior sheathing. I think that makes sense. We also like, if you're going to do rigid exterior insulation, to use a wood fiber insulation or a mineral wool. I believe there's also a hemp-based rigid insulation product that just came out on the market. So these are all vapor open exterior sheathings. So during the heating season, when you're heating up the inside of the home and that water vapor naturally want to move through the wall, it can move all the way out into that rain screen and out into the natural world. In very cold climates as well, oftentimes we'll see a vapor control layer on the interior side of the wall at the sheathing, and then placing the insulation completely on the outside of the structural sheathing. So what this does is it minimizes your condensation risk because there is not a condensing layer because that sheathing layer is on the inside. So on the left-hand side here, we can see this vapor control layer is going to be the taped OSB. And then on the right-hand side, this is our Intello X membrane, which is very similar to Intello Plus that you can see behind me. And this is an interior air and vapor control membrane. So in cold climates, if you're going to add a vapor retarding material, we want to have it on the interior side of the insulation. So interior on the right, exterior on the left. And the reason for that is during the heating season, when that water vapor wants to go to the cold side, we're preventing that water vapor from getting into the wall in the first place. Now, there's many products that you can use for this interior vapor control membrane. You can use OSB with tape seams, plywood with tape seams, vapor variable membranes, or smart vapor variable membranes. And so the benefit of going with a smart vapor variable membrane is that it has the greatest range of permeability. So it's going to prevent moisture from getting into the walls in the wintertime the best, and it's also going to open up the best as well, which will make more sense with this chart. So Intello Plus, product that we sell made by Proclima, it's been designed to have a very low perm rating at low levels of humidity. Because if you think about when you're heating your house, you're going to be at maybe 30 to 50% relative humidity. So at that humidity level, the Intello Plus membrane stays very vapor closed, right? We're less than 1 perm, so which is a class 2 vapor retarder. But like we were talking about earlier, if you had a window leak in the wintertime, there's lots of moisture in your wall, you have the western sun come and start baking that wall, it's going to push all that water vapor into the building. And so once Intello experiences about 80, 90% relative humidity, it actually opens up completely to 13 perms, which is not considered a vapor retarder. Perfect. So that concludes my section on water, air, and vapor control. And now I will talk a bit more specifically about the Proclima system and one project in particular in California that's looking to meet the PHI standard. So Proclima is manufactured and designed in Germany. They've been around for 30 years and they sell products all over the world. 475 only sells, 20 or 30 products from Proclima, but they have made hundreds because there are all types of construction throughout the world. So it's really fun to work with them because they can create new products specifically for the US market, or we can take products from other markets and use them in our market as well. So it's a toolkit. We've got everything you need to create water, air, and vapor control. So we've got gaskets, roof underlayments, we've got liquid applied membranes, window flashing tapes, peel and stick membranes, all that fun stuff. All right, so Adhero 3000 is a really popular product in California, especially for passive house construction. And the reason for that is it's a peel and stick membrane. It's essentially a giant roll of tape that you apply to the exterior side of the building. The benefit of using a peel and stick membrane is you're actually stuck to the sheathing. So if you have a hole in your membrane, here and you have a hole in your sheathing over there, those two holes can't connect because the material is actually stuck to the structure. If you were using a mechanically fastened membrane and that's kind of just sitting here, you can have air and water move between the sheathing and the WRB. So that's not great for meeting really high levels of air tightness with respect to the passive house standard. So many of our customers just end up doing Adhero because they want to minimize the chance of death by 1,000 cuts by tiny perforations in the material. Oops. All right, so this is a specific passive house project in California. It's being built by Good Space High Performance Builders. It's the first passive house, certified passive house in Sacramento. It was designed by Passive House BB, which is Bronwyn Berry's operation, and a number of the envelope and installation details were implemented by Mr. Installation, who's also based in the Bay Area. So this is a nice detail here, which I really wanted to share. And what this shows is a crawl space foundation. So crawl spaces in general are going to be more affordable than a slab on grade. It's relatively easy to connect your wall air barrier to your floor air barrier in a slab on grade foundation because essentially all you need to do is connect that WRB to the foundation wall. But for a crawl space, we have to somehow transition this air barrier from the outside of the wall to the inside. And we can either do that, on top of the framed floor, we can do it underneath the joists in the crawl space. And what I really like about this detail is that we're not asking anyone to do um, anything related to the air barrier in the crawl space, which is a dark, cramped area that nobody wants to spend any amount of time in, right? So on this project, they framed the floor and then they added the Adhero 3000 membrane onto that floor and then wrapped it down onto the stem wall. You could also do this in a lower cost way with our Tescon Vanatape if you taped the seams of the membrane. But with the Adhero, it's just a more durable approach for this specific air barrier. Um, and then again, you can see in that middle photo here that WRB, that Adhero 3000, it's right on the walls and it comes down the sheathing here, if you can see my mouse, and attaches to the Adhero that's already attached to the slab. So very simple detail to implement, very simple detail to verify, and not asking the trades or laborers to do anything difficult or time consuming in a narrow and uncomfortable space. Additionally, this house was designed with the monopoly approach. Kind of the monopoly framing is essentially when you wrap your WRB from the wall to the roof continuously, and then you build your eaves on afterwards. So the benefit of this with respect to air control and water control is it's very simple, right? We're just wrapping that same product, the Adhere 3000, from the wall onto the roof, and then onto the walls of the dormer there and onto the roof above the dormer. So it's a very simple application of the material. Like we talked about, it's a very durable material. It self-seals around fasteners. This project specifically is going to have rigid insulation, exterior insulation on the walls and roof. So there's going to be lots of temporary fasteners that are holding that insulation to the structure. And that peel and stick membrane is really going to minimize air leaks, even with hundreds or thousands of penetrations going through it. On this project, they could have used a mechanically fastened membrane by Proclima, maybe our Solitex Mento 3000 membrane. But like I said, that product is less durable when it comes to penetrations and potential air leaks. And then on the roof as well, anyone working on the roof is going to prefer working on a peel and stick product, something that's not going to move around on them. If you just have a material that's stapled to the roof, with taped seams that folks are walking all over, it could be subject to greater damage or greater risk. Another interesting detail with this roof is you can see there's an E vent, and this 2x4 is actually creating a channel where air can move. So just like a vented attic, if there's moisture that's being created inside the space, that water vapor moves up through the sheathing, the Adhero 3000, and the wood fiber insulation. it can move up into this channel and move up and out through the roof assembly, just like a vented attic. So we can dry outwards in this roof assembly, which is really important and really great for durability. It does have two layers of sheathing. It's essentially got two layers of underlayment and then a metal roof. So it's not necessarily the most cost-effective solution, but it is a going to be a beautiful solution. It's going to provide that venting to allow water vapor to get out, and it's going to be really great for the installers to work with as well. A cheaper solution, let's say, would be to use typical trusses, right? How most homes are built with trusses and comp shingle. And if you're going to go this approach, then you can still use that same WRB on the exterior wall. You can still transition that very easily onto the raised floor and above the crawl space. And then what you can do is you can actually wrap the airtight layer over the top plate using a membrane, using plywood, or even using the top plate as your air barrier, and then connect that in with our Intello Plus or Intello X membrane on the underside of the ceiling. So again, this is a very cost-effective approach when it comes to materials and trying to squeeze passive house into maybe more existing types of construction, but there are some risks to it. So you have your trades, your plumbers, your electricians, all those folks, maybe your drywallers, and they're not going to be used to seeing an interior airtight membrane. And so they might put cuts in it because it's easily accessible. They might not understand why it's there, and they might degrade it pretty heavily. You'll also need to consider how many can lights you have, if you need to build down a dropped ceiling, so that we can bring the airtightness behind those can lights. So if we go back to this image here, if you've got a tradesperson working on the inside of the building, this is business as usual. You know, they can do whatever they want in here. They don't have to worry about a material getting in their way, or a material or degrading a material that's critical to meeting the passive house standard. So cheaper approach, but you may need to have more communication. There may be work that needs to be redone. So using an approach like this may be simpler, may cost more, but yeah, just a bit of food for thought for you all.
Yes, I had
Uh-huh,
one
Ross.
question about those two details. If those two details don't have a vapor retarder on the interior, like the wall?
Yeah, so this project did not use an interior air barrier like Intello Plus.
Okay,
It just used the Adhero 3000 WRB for the airtight layer.
all right. Thank you.
Uh-huh. And then I see Marco, thank you for the question, Ross. I see there is another question here. How do these roof assemblies perform in high fire areas? So I think both of these roofs here are vented roofs, right? So you would probably want to have some ember protection vents here, like the Vulcan vents, which would close up if you have high temperature and prevent embers from coming in. A lot of folks do end up going unvented in California because of the concern around fire. And when you do go unvented, it does limit your insulation choices a bit. Flat roofs can limit your insulation choices. It can limit your roof assembly choices. So um, if you do want to follow up with me, Marco, later, there are some additional details that I can share with you of other projects, but I don't have any unvented assemblies to share today. And we've seen, I think the Sacramento Passive House, they're not in a WUI zone, so there's probably a little more flexibility with venting. But even in WUI zones, we've seen vented rain screen walls and vented roofs. All right, let's just see if there are any other questions. Um, so this assembly, I'm not aware of it being constructed in California, but Bird's Mouth Construction up in Portland, they use this assembly quite a bit. They use it with scissor trusses and cathedral style roofs as well, and have a lot of success. All right, so ExoSeal Encores is another product from 475 that's very popular. It's designed for the sill and door protection. So these are flat door and window sills, and it's a completely waterproof tape that is flexible and stretchy. So you can place it into the rough opening and then stretch it onto the face of the wall. This is an image from Best Tex Contracting Design, Build, and Remodel. This is Jason Schreier here, and this is his noble passive house that he's currently building right now in Orange County. So another product that's really popular in California is this IQ tape. This IQ tape is pretty cool. It's just like Intello Plus in that it's vapor variable. So what's great about this tape is it can be used on the interior side of your windows for air tightness, and it can also be used on the exterior side for your water tightness as well. And it will, similar to Intello Plus, it will buffer that humidity from getting into between the window frame and the rough opening during the winter, but it's also able to open up and dry out in the summertime. It also connects to concrete without a primer, and it can be plastered over. So it can be used in EFIS type construction. It can be used with the FAS wall system. You can put stucco over it. So it comes in 3 and 6 inch wide, and it does have a couple relief strips on the backside, which you can see here in this picture just barely. So this is a one-stop shop tape that can be used in a lot of applications. And I think I mentioned this already, but it can be used at the bottom of the wall to connect to concrete. So if you're looking to seal up between the concrete and the plywood wall structure, all you need to do is place this tape on there, and you're sealed up nicely with being water and airtight. And so, I only showed you 4 products today, but I think these 4 products can be used on a variety of projects in a variety of applications. And it helps to simplify for your builder. I did do a project recently where a client purchased, I think, 15 to 20 different products from us for a single project. And I do worry that the person applying the product is going to use the wrong tape for certain applications, and it may just cause a bit of confusion. So on your end, if you can simplify the approach for your builder and for the laborers and use a small amount of products, these are the products I would recommend. These can really get you where you need to be for Passive House. And so I'm more than happy to connect with all of you after this call. I'm available via email, via phone call, or through a video call. And I look at hundreds, if not thousands of projects every year, be they retrofits, new construction, and they all have different wall, roof, and floor assemblies. And yeah, I really enjoy helping my clients with their water, air, and vapor control strategy. So don't hesitate to reach out. Feel free to take down my contact information, and that concludes my presentation today. So I'm happy to take on any other questions if you do have some.
A call to action for all of you, if you have the opportunity or interested, is to, now that you're smarter, you can do better things. But if you're interested in supporting Passive House California, you can sign up for our newsletter on the passivehousecal.org. Here, let me do that. So you can sign up for the newsletter. There are individual memberships, professional memberships. You can join as an organization, which includes some number of individual memberships besides depending on your choice. You can choose to sponsor or be a donor or volunteer. So it is an important and excellent thing to do. Going to the next, thank you for your attention. This info at passivehousecal.org is where you can get what you want. And those of you who are here are getting smarter, and you can make the people around you smarter. The image here is the only light that's lit is this light here in this graphic that goes around. And because we have another minute or two, we have a couple of quick things I'll share with you about Passive House California, or that I think might be worthwhile. The first one is the elements of decarbonization. Of course, California is very active in decarbonization in terms of electrifying everything, which is absolutely an important thing to do. But if you start with a building that is as efficient as possible, the lower the energy use, the more embodied carbon that it avoids. And then, of course, you want the embodied carbon. You want to limit the embodied carbon as much as you can, and then, of course, electrify everything and go with clean energy. The implication here is that this is the order in which you do it, and that is not the action. That is not the answer. The order that you do it in is over here when you put together your your architectural team, your construction team, the developer, everybody that's involved in it, and decide, doing an owner's project requirements, decide all of these things, what your outcome you'd like to have be. If it happens to be a building that is you're remodeling a building or retrofitting a building, you don't necessarily get to passive house, but what often happens when you're remodeling a building is you say, well, we got this much money to spend, so we're going to add some insulation here and some windows there and do this and that. And that's an anecdotal approach. Whereas if you take a modeling approach using the passive house planning package, and you can find out, you may not be able to logically, from an economic standpoint, go to all the way to passive house, but you can choose to back down in a way that everything is working together, so you wind up with a better result. And the final thing is just a quick to show you, we have a trifold brochure that we now have. And you can find this on and it starts with future ready buildings, comfort and resilience. And then when you pull that page back, you get over here to the different elements. And then you go to well, here I'll go down, you go to the inside. And on the inside, you learn about the things that are here. You can reach us by info@passivehousecal.org. And if you're interested in this, you can go to the passivhouse.cal website, and then go to resources and publications, and you can click down and you'll find this and have access to it. Or if you're attending a show or something and want to have some, we have access to them. So thank you for all of that. Thank you for your time and attention. Thank you, Kim, for putting it together. I will unshare my screen now, and we'll let Kim wrap it up if she would.
Great, wonderful. Well, we'll be back at it next month. Stay tuned for the announcement of our next featured presenter. And until next time, I hope everyone has a great day.
Thank you
Thanks,
all.
Kim.
Stay safe.
Bye, everyone.
Thank you. Bye.